All right, our first real geometry lesson, measuring segments and angles. So a lot of the vocabulary is going to be used in this section, so you need to make sure that you know your vocabulary. Make sure that when you come to class that you are asking questions. If you don't understand something from the lecture, from the notes, then you need to ask questions in class and make sure that you understand so that when you start the assignment, you can work through the assignment with little to no problems. Okay? If you don't ask, then I don't know that you don't know. All right, first postulate. It's a kind of a long one. It's called the ruler postulate. What it says is the points of a line can be put in a one-to-one correspondence with the real numbers so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers. So what that means is that if we have a number line, so I'll draw a number line, and let's say, these are all the numbers along the number line. Okay, here's 0. So it's saying that if I have a segment, and we'll make the segment a different color, segment like that, then I can take that segment and I can put it on the number line and I can tell how long it is. Okay? Distance is always an absolute value because you can't have a negative distance. If you've ever watched Ferris Bueller's Day Off, they try to run the car in reverse and they can't get the miles off the car because as you go in any direction, it's still a positive distance. Okay? So this line is still 3 long because it's an absolute value. You would just take 0 minus negative 3 and take the absolute value of it. All right, congruent segments. This is the first vocab word of this, and you need to know what congruent means. You're going to hear it the rest of the year. Okay? Congruent segments are 2 segments with the same length. Congruent means the same. So if you hear me say that, it's kind of like equals, but I'll explain that difference later in the year. When we write this, we can say that the 2 segments are equal. This is usually when we know the distance, we know their lengths. Okay, so we know that both of those segments are 3 inches long or something like that. This, the equals with the tilde over, is a congruent symbol. Okay, so you better make sure we got that under control. We'll put congruent. So anytime you write the word congruent, you can just put the little symbol. Okay, this we use if we don't know lengths. So we just know they're the same, but we don't know how long they are. Then we use congruent. Okay, I won't get too picky if you use one instead of the other, but I want you to get in a good habit of using congruent when we don't know lengths and equal when we do know lengths. Okay, they essentially mean the same thing. All right, congruent segments are also marked alike to show that they are congruent. So let's say in a picture we have 2 segments. There's one, and we'll have this one. And let's say they are equal. Then I will go to them and I will put a mark on both of them. Those are congruent marks. And if we have more than one set of congruent segments, some of them will have 2 marks or 3 marks or 4 marks or however many. You can go up as many marks as you need. Eventually it gets redundant. Normally, most of our pictures will have 1, 2, or 3 marks. Okay? So anytime you see these little tick marks, those mean congruent. All right. So let's try this. This is the ruler postulate. It wants to know, is AB and BC congruent? So here's AB right here. And here's BC. It wants to know if they're congruent. So if you look, AB goes from -9 to -5. That's 4. BC goes from -5 to -1. That is also 4. So yes, they are congruent. Okay, you just have to figure out how long each one of them is, and if they're the same, then they're congruent. All right, this is a big postulate. You need to make sure you highlight it, you put a box around it, whatever you need to do so that you can come back and look at this again. We will use this postulate most of the rest of the year. Okay, segment addition postulates. So what it says is if 3 points, A, B, and C, are collinear, there's that word. You should know what this means. So here's my line. And we'll put A, B, C because it says that B is between A and C. Then if you take AB plus BC, you will get AC. Okay? Think small segment plus small segment equals bigger segment. Okay? And this equation right here we're going to plug in some algebra stuff to it and do some algebra. And you'll get very familiar with it very quickly. All right, so let's try this. It says dt is 60. So dt, this whole thing, is 60. And it wants us to find the value of x and then find ds and st. We'll do those in a minute. So if the whole thing is 60, then we need to add up the two parts that make it in order to get 60. So then we're going to take ds, which is 2x minus 8, plus st, this 3x minus 12, and that all has to equal 60 when it's added together. So now we can do our algebra. You can do it however you wish. If it was me, I would combine like terms first. And when you combine like terms on the left side, you do not do the opposite. I don't subtract 2x. Okay? They get added because they're on the same side. Negative 8 and negative 12 just go together and make negative 20. Okay? It's only opposite if you go across the equal. All right, so now I'm going to add 20 to both sides and then divide by 5 and get x to be 16. That was part of our question. Then they ask us to find ds and st. So in order to do that, you have to plug in the 16 into the problem right there and right there and figure out what those two are. Okay, so for ds, we plug in 16. We take 2 times 16, which is 32, minus 8 gives us 24. And then st, do 3 times 16 is 48, minus 12 is 36. Now remember that that whole segment has to be 60. So if we add ds and st together, we better get 60. And that happens to be the case, so we're good. Okay, 3 answers. You're going to have to start watching your problems now because they're going to have you find x and the segment length sometimes. So you need to make sure that you finish the problem. Okay, let's try another one. This one gives us a different word. The midpoint. Midpoint means middle. Okay, so C is in the middle of the segment. And whenever C is in the middle, that means that both the left side and the right side are equal. Okay? Because this one, they don't give us how long AB is. They just tell us that C is in the middle. So we have to set the two pieces equal to each other to solve this one. Okay? Midpoint should be your first clue on how to set this up. If they give you the length of the whole segment, then you set it up like example 2. All right, so here I'm going to subtract 2x from both sides, and I'm going to add 4 to both sides and get x equals 5. But that's not what they asked for. They want AC, CB, and AB. So for AC, we're going to plug in 5. 2 times 5 is 10, plus 1 is 11. CB, if you're really resourceful here, you would remember that we said those two segments were equal. So it also has to be 11, but we can plug it in and check. If we put in a 5 right here, 3 times 5 is 15, minus 4 is 11. And then AB is the entire segment, so we have to add both pieces together and get 22. All right, on to angles. These are formed by two rays with the same endpoint. So picture in my picture there would be an arrow past A because it's a ray, and there'd be an arrow past C. I just can't draw it with Sketchpad. Okay, to name these, this angle actually has 3 different names. Okay, the first one, you see the number in the angle, it can be called angle 1. We'll use that one quite a bit. You can also name it angle B. Angle B is if the point of the angle, the vertex of the angle, is by itself. If there's other angles at B, then we can't just say angle B. Okay? And then the surefire way to make sure that we know exactly what angle we're talking about, you name it by 3 letters with the vertex in the middle. So we would go A, B, C. It would be angle A, B, C. Okay? The vertex has to go in the middle in order to do that. That is the preferred way of naming an angle, unless there is a number there. Okay? That's kind of a big deal whenever we get to proofs. All right, so for this picture, let's start naming angles. First thing I see is there's 2 of them with numbers. So let's name those and get those out of the way. Okay, we could do angle B, but angle B is this whole angle here. It's not just one or the other, it's the whole thing. Okay, angle B is the same as angle A, B, D. This is D down here. Okay, those are the same thing. Angle 1 is actually the same as angle ABC. And then angle 2 is actually the same as angle CBD. You notice I put B in the middle of all 3 of those because B is the vertex, so it has to go in the middle. Okay, so technically there's 3 angles in this picture, but we can name 6 different ways of doing it. Whoops. All right, to classify angles, these words should look really familiar. You should know these right off the top of your head, okay? An acute angle is an angle between 0 and 90. And you notice I put between 0 and 90. If you just say less than 90, then I'd be a smart aleck and say it could be a negative 10-degree angle, which is not true. Okay, so it's an angle between 0 and 90. A right angle is 90 degrees straight up. An obtuse angle is an angle between 90 and 180 degrees. It can't be 90 because then it'd be right. It can't be 180 because then it would be a straight angle. So it has to be somewhere between. Okay? Got to know the terminology so you can handle being in geometry because we speak a lot of language. All right, congruent angles. These are angles with the same measure. So in this picture, angle 1 and angle 2 are the same thing. In a picture, if angles are the same, they'll have these little arcs on them. And angles that have the same number of arcs are congruent. Okay? There's 2 ways to write this. Okay? You can put M angle 1 equals M angle 2. The M means measure of angle 1 and the measure of angle 2. Okay, so this would be if we know the measure, we know they're both 40 degrees, then we can put measure of angle 1 and measure of angle 2. The second one, we use the congruent symbol, so we know they're the same, but we don't know how big they are. Then we'll put angle 1 is congruent to angle 2. Okay, kind of pay attention to how you're supposed to write these and it'll be okay. All right, angle addition postulate. This is another big one that you probably should highlight or put a box around or something like that. They're saying if point B is in the interior of angle AOC, so you see the picture, how B is inside the mouth of AOC, then they're saying that the angle on the left plus the angle on the right equal the whole angle. So picture small angle plus small angle equals big angle. Okay, just like segment addition postulate. All right, now this one has a twist Because if AOC happens to be a straight angle, so it's a straight line, but it's got this line here making two angles, then they're saying the left angle plus the right angle equals 180. Okay, so that's just a special case within this theorem. All right, so let's go use it. So they're asking, what is the measure of angle TSW if RST is 50 degrees and RSW is 125? So RSW is this whole angle is 125. Okay, so TSW, if you add it with RST, then you would get 125. So 50 plus something equals 125. We'll write that down. 50 plus something equals 125. So by our vast mathematic abilities, we know that angle is 75 degrees. Okay? Because they have to add up to 125. That's angle addition postulate. Okay, some angle pairs that we need to throw in here. Vertical angles. These are angles that if you have an intersection, you have two lines that intersect like that. These are angles that are across from each other, across an intersection. So 2 and 4 are vertical and 1 and 3 are vertical. There is a theorem coming very soon that says vertical angles are congruent. So actually, 2 is congruent to 4 and 1 is congruent to 3. Okay? Second one, adjacent angles. Adjacent being right next to each other. So angle 1 and angle 2 are adjacent angles because they're right next to each other. They don't have to make 180. They just have to be right next to each other. Two more, complementary and supplementary. Complementary angles mean that they add up to 90 degrees. Okay, so in this picture, angle 1 and angle 2 add up to 90 degrees. And then supplementary angles add up to 180 degrees. So in this picture, angle 1 and angle 2 add up to 180 degrees, a straight angle. Okay, these are kind of important vocab words. These will pop up a lot. All right, so in this picture, let's give a pair of complementary angles. You see the box over here? This box right here? That means right angle. That means 90 degrees. So that means angle 2 and angle 3 are complementary because they both together make a right angle. A pair of supplementary angles, and there's several different pairs in this picture, but I'll just pick one. Angle 5 and angle 4. Okay, so if you look at angle 5 and angle 4, the two of them together make a straight line, so they're supplementary. And then vertical angles, they have to be right straight across from the intersection from each other. So I'm going to put angle 5 and angle 3. Okay, because if you look at the intersection here, I'll draw this a little better. Here's the intersection right here. There's angle 5 and angle 3 as the vertical angles. Okay? So to wrap this up, these are some assumptions that you can make according to everything. You can conclude from the picture that angles are adjacent. That angles are adjacent and supplementary because you can see that it's a straight line. And you can assume that they are vertical angles because we can see the intersection. But unless there are marks, you cannot assume that anything is congruent, any angles or segments. Unless I mark the picture, you cannot assume they're congruent. You also cannot assume right angles unless there is a box in the corner. I will put an 89-degree angle on something just to throw you off. Look for the marks. And then you cannot assume lines are parallel or perpendicular without marks, and I'll show you what those marks look like later. Okay?